Hello and greetings everyone, dear ISEC 2021 conference participants. I'm Neo4j, a teaching assistant at the Faculty of Electronic Engineering, University of Niš, Serbia, from the Department of Computer Science. Now I present you my paper, which is entitled Booking Cancellation Prediction Relying on Graph Database in Neo4j. It is quite noticeable that the ongoing COVID-19 pandemic has affected dramatically tourism sector as well. Travel restrictions and other government measures taken as a response due to current situation have caused many negative impacts and consequences when it comes to overall tourist number worldwide, number of flights, reservations, and also as a side effect it caused a huge number of lost jobs. However, it is identified that the state-of-art information technology is actually quite beneficial and has huge potential when it comes to revival of tourism under these novel circumstances. To be more precise, machine learning and artificial intelligence, as they enable to extract hidden knowledge from huge amounts of data. Here, the idea is actually to leverage the traveler and booking reservation data. In this paper, I explore how the subclass of so-called machine learning algorithms belonging to classification methods can be actually leveraged in order to predict proactively whether a booking will be cancelled or no. For implementation, I rely on Neo4j's graph database, graph data science library, and finally, I evaluate the proposed model on a publicly available open dataset from Kaggle. Now let's see some Neo4j basics. So it is actually a graph database model which has three main concepts. The first one is no. It actually corresponds to some particular domain entity. Like if we have particular domain like tourism, it can be like tourist, like hotel, like reservation. Moreover, we have edges that establish the connections between these nodes. So the relationships are actually also another important concept in graph database. And the third one is actually the property which is used to describe either model, either entity or edge in more details. Finally, we have Cypher declarative query language provided by Neo4j, which is used to specify which nodes and edges we want to extract for a particular purpose. Since 2020, Neo4j has become not only graph database but also machine learning platform, as it included graph data science library. However, it covers only two aspects of machine learning, classification and relationship discovery. Despite its limited set of features, in many works it is stated that execution times when it comes to performance are actually quite competitive to other solutions. Now let's see some about classification in general. So when we talk about classification, the goal is actually to specify the correct label of given input example from the data set. However, in order to make new predictions, it is necessary to adjust the weights actually to train our model by observing correctly classified data, as here we use supervised learning method. Once the training is completed, we evaluate the created model with respect to some metric. It can be, when it comes to classification, what is the most commonly used. Even in Neo4j, it is provided in its API, are accuracy and F-score. Accuracy is the ratio of correctly classified examples against the overall number of examples in the dataset, and on the other side, F-score, which is a bit different ratio of true positives and false positives and false negatives. In Neo4j, the actual function used in order to train classification model is called GDS alpha M1 node classification.train. Each call of this function actually performs training for desired set of features, and actually we need to specify which are the input features and what is the output, what is the target. But apart from that, and apart from some additional fine-tuning parameters for classification, we can also specify different candidate models, so they will be evaluated against the desired metric, and the one with the highest score according to specified desired metric will be stored and returned in the Neo4j local catalog. Here, on this slide, we see the main Neo4j classification algorithm elements. The first is model name. So once training is done, the candidate model with highest score will be stored in local catalog under this name. Feature properties actually represent inputs, actually the independent variables which are used for classification method. So in our case, it would be like the number of previous cancellations, hotel ID, something that is like input of the classification algorithm itself. On the other side, we have target property, actually the label of a class. So in our case, we only treat problem as binary classification. We have two possible outcomes, like the reservation will be cancelled or no, 0 or 1. So in our case, it's like integer value. In general, in classification, we can have many different possible labels, or to be even more general, in classification we can have overlapping classes, but here we have only two distinct classes, cancellation occurs or no. Holdout fraction actually is the percentage of train set reserved for testing purpose. So how we want to split the overall data set into training and test set. So if we have here value 0.2, 20% of the data set would be for test purpose and 80 for training. Validation faults is also one more parameter which is used in order to split the data set, like the number of train graph divisions used for model selections. Furthermore, we have matrix. As I already told, these two are supported. F1 score, here given in two possible variants, F1 weighted and F1 macro, and accuracy on the other side. And they are used to estimate the candidate models, while the candidate models themselves are specified within the param section. So in this list of parameters, we have to specify a set of other parameters, not all of them. We can actually select only few of them that we want to adjust. So they are shown in this other table, and here when we specified these candidate models using the proposed parameters offered by Neo4j, then it will evaluate the created models after training against the selected metrics, and then it will only store the one with the highest score. A random seed is another parameter which is also adjustable in Neo4j and is basis for random number generated used in training phase, but to be more specific in weight initialization. Now let's see which are actually the candidate model parameters. First one is penalty. It's learning rate value of the model. It's commonly called alpha or something like this in other frameworks, and it says how much the weights will be adjusted and modified when we observe some new data. So it depends on the error that we get during classification and how much this new information would affect the classifications in future. Batch size is the number of observations used for training within one iteration. Like what is actually the number of nodes that we want to use in one training iteration. So after that, we have two parameters adjusting the minimum and maximum number of training epochs. So how many times minimally we can pass through the data set and what is the maximum number of times. So it can be like considered as a fine-tuning of the algorithm, but in combination with these two, patience and tolerance. So they specified on first place patience as maximum number of performed iterations without improvement of loss value without stopping. And tolerance on the other side is minimum value of acceptable loss. So all these four parameters in general can be leveraged in order to specify when the training would stop, like which are the stopping conditions for training phase. If we set this number too high, it can occur that a model would start overfitting. If we have too small number of minimum epochs, it can happen that accuracy or F1 score would be poor. So finding the right balance between these parameters in combination with stopping conditions is actually what is done experimentally, and it gives us ability actually to observe experimentally how the algorithm behaves and the one with the best possible score will be returned as outcome of training process. Now let's see the implementation of the proposed hotel cancellation prediction model. In the first step, before I continue, I want to say that what you see in this slide is actually the overall workflow of classification in Neo4j. So in the first step, we have to load the desired data. In this case, I use CSV file, and for this purpose, I use load CSV with headers from command. As argument, I have to provide the correct path on disk or somewhere online, and after that, I have to actually import the table as a form of rows, as a set of rows into Neo4j. So I say load CSV with headers from file hotel booking CSV as row with. So now I specify which parameters are actually condition whether I will load the row or not. So I say where row.hotel is not null. So if there is some reservation without hotel identifier, I won't load it. Moreover, after that I say merge and say which is the alias of each inserted row. So it would be B, and it corresponds to booking labels. So here in Neo4j we can put labels for nodes. So as outcome, later when we create the overall graph, they will be labeled as booking. And now we specify in these brackets the desired parameters that I wanted to extract from hotel booking CSV file. And I say, for example, hotel identifier, is it cancelled or no, a lead time, stays in week, and so on. Once loading is done, I still cannot directly apply a classification algorithm on the data. Before that, Neo4j requires to construct a graph. So the input of classification train method is actually graph, but still I have a set of rows. So in order to transform this set of rows into a graph, I call GDS graph create cipher query. So this query for graph creation has three main parameters. The first one is actually the graph name, how the future graph will be called, something that I create as outcome of this procedure, what will be the name of that graph. The second parameter is query string, the cipher query string, which extracts the desired set of nodes from the dataset. And the third one is actually used to form the links between the extracted nodes. So despite the fact that I don't have any real relationships in this dataset, I have to specify as Neo4j requires. So it will actually return an empty set of relationships between nodes, but what is useful data here are actually the important nodes. So after that, once I have the graph, I have to actually perform manual steps of selecting the desired features from the imported features, select the model parameters, like to decide what would be actually the tuning parameters, like I said here, and to choose the evaluation metric, so whether it would be one or another variant of F1, score of or accuracy. And after that, after I bring all these decisions, I can actually write the execution invocation of a train method. So the first parameter is the name of the previously created graph, and I called it booking graph, so it would be the first parameter here. After that, I have to specify all these parameters. Feature properties, as I already said, are the independent variables. So here I extracted from dataset useful data like lead time, number of previous cancellations by the user, stays in nights, and so on. On the other side, I have to specify the desired target property, what is actually the class label. It is a binary variable, is cancelled. Moreover, I specify random seed value, it's 2, a basis for a random number generator. Holdout fraction, I say 0.2 as I want to split actually the dataset in the following way, like 80% training, 20% test. So I put 0.2. Validation faults, I already mentioned these parameters like the number of how many times the graph is split. And I select the desired evaluation metric. In this case, it would be accuracy in this example of query. And now I specified parameters for candidate models. I don't have to specify all parameters for each of the candidates. I can select only few of them and specify. For the first one, for example, I put penalty 0.07, maximum number of epochs, and batch size. On the other side, for some other, I put only penalty 0.8. Once all these models are trained, they would be evaluated using the accuracy metric in this case. And finally, I say yield model info, as I want to leverage further the info about the created models and actually to see which one performed the best and store it into a catalog. For this purpose, I write these 3 lines. So the one with best parameters regarding the accuracy will be returned and stored into catalog. Now let's see which are the outcomes of the proposed model regarding 2 different aspects. One is execution time and another one is actually the model performance in this matrix. The evaluation was performed on machine with given specification. It was actually a laptop equipped with Intel i7 quad-core processor and 16 gigabytes of DDR4 RAM and 1 SSD disk. For execution time, I split it for distinct steps. So we can see how much time it takes for model import, graph creation, and training. For training on with respect to different number of candidate models. So it is noticeable that model import lasts the most, like 49 seconds. It is quite expected as the number of records within the CSV file is more than 10,000. So this is actually the execution time for this query. On the other side, graph creation is this query and it lasts about 0.19 seconds. It's quite fast. Once we have the data imported into Neo4j, it doesn't take too much time to construct the graph. And the third parameter, the third step is actually training time when we execute such type of query. In the first case, it is for 2 candidate models, these 2 that I shown, but in the other case, we have 8 candidate models. And it is noticeable that for a larger number of model candidates, the time increases, which is expected, as we need to evaluate, actually both train and evaluate all these models. And what is here also interesting is that the execution time for classification training is really very promising, as for such large number of nodes, it lasts less than 1 second, even for 8 different candidate models. And on the other side, I evaluate the performance of the proposed model with respect to accuracy and F1 score for different values of parameters. And in the right column, you can see actually the conditions of this experiment. Like the first half represents the values obtained for training set, and the later part is actually for test set. It is quite expected that on train set it has better performance. You can see it slightly better with respect to both accuracy and F1 score. And this is it when it comes to performance. It's acceptable for this kind of problem. And finally, before summing up, let's see how was the data set structured. You can see the link where I took this data set from. It's available publicly on Kaggle. It contains about 10,502 records that are complete with all the fields, and they were imported into Neo4j graph. As I already told, I split it in this ratio: 80% training, 20 test. This is the set of features given in table. So the first feature here is actually the target, the outcome of classification, and it says whether cancellation of this reservation would occur or no. Moreover, for each of the reservations, we had the hotel identifier, lead time, which is the number of days between booking creation and arrival date, and moreover, it is also interesting to include arrival date, year, month, week, and day, specifying the exact time when the tourists have to arrive. Moreover, we also have two relevant aspects that would contribute to predicting whether cancellation would occur or no, are actually previous number of cancellations. So if some person is already canceling in past, had already cancelled several bookings in past, it is expected to even do it in future. On the other side, previous bookings not cancelled is opposite. It's actually the number of past travels without cancellation. Furthermore, we have the number of adults and children within the reservation, identifier of country destination, total number of nights, type of the reserved room. It can be like economy class, like luxury room, and so on, denoted in chars from A to H. And the Boolean variable, which is called isRepeatedGuest, and it says whether someone has already visited the same destination before in the same hotel. So it is like more likely that cancellation won't occur if the person frequently visits that destination. Now let's sum up. In this paper, a classification approach based on Neo4j graph was adopted in case of hotel booking cancellation prediction problem. According to the obtained results, the approach shows promising performance, which is quite acceptable for this type of problem, and on the other side, quite fast execution times, which is also important, as we have huge amount of data which was analyzed in these experiments. In near future, it is planned actually to augment the proposed model and also to include the data about COVID-19 related factors, like number of new cases for each country, like number of deaths, also the information about government measures like requirements for vaccination, PCR or other tests, or green certificates, and travel prohibitions. So even this information is expected to actually contribute and to enable more accurate predictions. Thank you for your attention. This work has been supported by the Ministry of Education, Science and Technological Development of the Republic of Serbia.